हाँ जी, गुड आफ्टरनून सर। हेलो।
Hello.
Anji, good afternoon, sir.
Good afternoon, Ji. Sir.
Thank you for joining us.
Okay. Most welcome.
So, dear participants, I welcome you again in the session 8th of our fourth day. So, for this session, we have with us Shri Vishwaranjan Das ji. Sir is working as an assistant professor in Department of Computer Science and Engineering, RN Institute of Engineering and Technology, Bhubaneswar, Odisha, and also as guest faculty in Center for Translation and Digital Humanities, Ravin Shah University, Cuttack. His research areas are natural language processing and computational linguistics, along with machine translation, information retrieval, sentiment analysis using artificial intelligence and machine learning. Sir has published more than 50 research papers, including journal papers, book chapters, and also published conference papers and attended more than 50 conferences, seminars, workshops, short-term courses in online as well as offline mode. And he has presented his research in various institutions like IIT, NIT, ISI, and various central universities also. Sir is also an author of the book with the renowned famous professors Professor Amiya Rath and Professor Satchidanand Dehuri, and lot more in the credit of Shri Vishwa Ranjan Das ji. So, sir, I welcome you here in the 8th session of our 1 week online faculty development program on machine learning concepts and applications. You have spared time for us, so I am very thankful to you. Now, I request Shri Vishwa Ranjan Das ji to start with his presentation. Thank you, sir.
Okay, okay. Okay, thank you, Dr. Sastri ji. So, really it is very nice introduction. Sir, am I audible? Hello, am I audible, sir? Please confirm.
Yes, sir. Yes, sir. You are audible.
Okay, thank you. Thank you, sir. Thank you. Thank you, Professor Sastri.
Hello, sir. I think there is some technical glitch at his side, so let's wait for 2 minutes.
Okay, I am extremely sorry.
No issues, sir.
Sir. Oh, I'm extremely sorry because of some technical problem is here. Okay, so I want to share my screen first. Sir, is it visible? Please come.
Yes, sir.
Okay. Okay. So, so myself Viswaranjan Das, assistant professor, Aryan Institute of Engineering and Technology, Department of Computer Science Engineering. So I am going to deliver my talk that is based on natural language text analysis and processing using machine learning algorithm. First we will see what is natural language, then we go for text analysis based on natural language, then we go for processing. Processing is actually the part of practical, actually the part of implementation you can say. Okay. Next we first we discuss the what is exactly the natural language processing is. Okay, it is a medium of communication. Natural language basically the medium of communication between the human being, okay, or among the human being. Okay, natural language that is basically spoken by the people. Okay. Now if we say natural language processing, basically a subfield of artificially intelligence and linguistics to make computer understand statement written in human language or written by human language. Basically, it's a subfield of artificially intelligence and the linguistics to make computer understand. First of all, computer will understand what user giving as the data. Okay. Next, after understanding whatever data inputted by the user, that will be understand by the computer, then computer automatically generate another text that is based on natural language text. Okay. Now, this natural language processing divided into two parts. One is natural language understanding, another is natural language generation. Now, first computer will understand, then it will generate automatically in the form of text. That means another text, in a text of another text based on another language. What is input, what is process, and what is output. First input is the natural language text. First we have to input, then machine will automatically process the natural language. Whatever natural text we have inputted before, that will be processed by the computer. After processing, computer will generate another text that is based on in the same language or different language. So what are the natural language? So different natural languages are there. For example, Odia, Hindi, Bengali, Tamil, Telugu, French, Japanese, these are all natural language because that language are spoken by the people basically. But if we say natural language processing, that means it is purely based on artificially intelligence and some machine learning algorithm. Okay. So this is all about your natural language processing, and this is the types of different types of natural language processing. Now, the traditional natural language processing, statistical natural language processing, cognitive natural language processing, computational NLP, neural or neuro NLP, and the quantum NLP or natural language processing. Okay. Now, these are the different types. Traditional NLP means that is purely based on the literature people. But on statistical NLP onwards, whatever NLP are mentioned over here, statistical, cognitive, computational, neuro, and quantum, that is fully based on the that means we can say that is purely based on the corpus based, we can say corpus based natural language processing. Okay, these are the different types of natural language processing. Next, what is artificially intelligence and what is machine learning? First, sometime machine intelligence called artificial intelligence. Actually, what is the definition? The ability to learn something. That means ability to learn knowledge, perceive knowledge, and start working accordingly the human being. That is called artificial intelligence. That means a machine or a model just behave like a human being from the training set or training data set, we can say. And the machine learning is what that I think this machine learning, the definition of the machine learning, all of you acquainted with this. It's basically a branch of artificial intelligence and computer science, which focus on the use of data and algorithm. This is very important for in case of machine learning. That machine learning purely based on data and computational algorithm or mathematical algorithm to imitate the way that human learn, gradually improve its accuracy. This is the secondary thing, gradually improve its accuracy. First thing is the machine, through machine learning. First, machine will learn. How to learn? The machine will learn from the different types of data, whether it is unstructured data or whether it is structured data. It will be better for machine to understand the structured data, okay, not for unstructured data. Now, how machine learning is used in LLP? This is very important. In my talk, actually, how machine learning algorithm is used in case of natural language processing, that we will see. Okay. Now, according to Alan Turing in 1900, sorry, this is actually 1995. By mistake, it has written 195. That is actually 1995. Now, actually, he told that can a machine think? This is very important. Can a machine think? Yes, machine can think partially. Practically did it. Machine not 100%, but partially machine can think. Okay, let us see how machine can think. Okay, I will show you how machine can think. Okay. Okay, and the next thing is the linguistic. What the term linguistic? What is the meaning of linguistic? This is actually the science of language. Linguistic means the science of language. Okay. Now it includes the different steps and phases. What are the different steps and phases? The first phases or steps is sound, and the second is word formation, sentence structure, meaning, understanding, and discourse. Okay, let us discuss one by one. Okay, in the next slide, and this is the level of linguistic analysis. First, the acoustic signal, then phone, letters, morpheme, word, phrase, and sentence, meaning out of context and meaning in context. This is the level of linguistic analysis. Next, we go to the steps of NLP. What are the different types of steps in NLP? Phonology and the phonetics. That is purely based on speech processing. Actually, that is not my work. My work is purely based on text processing. Only text processing. Whatever research I have done, that is purely based on text data. Okay, not for speech data. Okay, phonology. But these are the steps included in case of in NLP. Okay, phonology and phonetics. This is the first step of natural language processing, but that is not my area. My area from here: morphological analysis, lexical analysis, syntactic analysis, semantic analysis, discourse integration or discourse analysis. You can say pragmatic analysis. What do you mean by morphological analysis? That means the word formation. Morphological, basically the word formation. Next slide. In morphological, that what it will show the in case of morphological analysis, you will show the entire grammatical structure of a word or of the words. That means word formation. It will display the entire. It will show the entire grammatical structure of a particular word. The grammatical structure of a particular word means the sense, the tense, the danger, the gender, everything it will show. Next is the lexical analysis. That means the collection of information about words. That is in case of, you can say in other words, that is word in dictionary. In the dictionary you have seen might be the word of a particular word. In that word is in which form, whether it is in noun form or whether it is in verb form, whether it is in adjective form. It will display everything if you go for lexical analysis. Next is syntactic analysis. That means the grammatical structure of the sentence. Syntactic analysis means the grammatical structure of the sentence. That means analysis of a word in the sentence. Now you see here I have taken one example. Going I to school am. Okay. Now actually the sentence is I am going to school. Okay. Now here first I have written the main verb, then subject, then preposition, then noun, then helping verb. You can say. Now syntactically it is correct. How syntactically it is correct? Now if you see the am is there, the helping verb am is there. That means the main verb should be in the form of ing. Next is I, next is to, next is school. But semantically it is not correct. Semantic, there is no meaning of this sentence, but it is syntactically correct. Why it is syntactically correct? Now if you analyze each and every word, grammatically it is correct. Grammatically it is correct, but the word order of this particular sentence is not correct. So there is no meaning. But in case of semantic analysis, what it produces? It produces the possible meaning of the sentence. That means it drives the absolute meaning of the sentence in a context. Context means here the context is I am going to school. Here that is semantically it is correct, but in the previous sentence that is syntactically correct. Okay. Next is discourse analysis, meaning from compound sentence. Now compound sentence, there are more than one sentences are there. From more than one sentence or from the sentences, you have to find the exact meaning of a particular sentence. That sentence is based on the previous four sentence or the compound sentence. From the compound sentence, you have to find the meaning of another sentence is called discourse analysis. Now you see that is what it expresses our feelings. Now if you say, suppose I am telling three sentences. What are the three sentences? You just mark it. The first sentence, I am a very rich man. Okay. I have 4 bungalows. I have lots of money. Okay, but still I ride bicycle. What is the meaning of still I ride bicycle? What is the meaning of this out of these previous sentences? So क्या पता चला रहा कि वो वाला कंजूसी का पता चल रहा कि वो वाला, because I ride bicycle, because I have lots of money, I have huge number of assets are there. So out of these you have to generate the meaning. You have to generate the meaning of a particular sentence is called discourse analysis. Next is pragmatic analysis. That means the derived knowledge from the external common sense. Now, how to derive knowledge? Now you see one example: the door is open. In which sense I am telling that the door is open? What is the actual meaning of the door is sentence? Sometimes your mother and your father say to child or kids, and then the door is open. What is the meaning? Maybe some cats or dog maybe enter into your home. That is the meaning. Now, maybe another meaning is, now I am going outside, so our door is open, you please close it. That is the meaning. So exact meaning that you have to find, that is called your pragmatic analysis. How to find the exact meaning of a particular sentence is called pragmatic analysis. Next, we proceed to morphological analysis. This is the first step of natural language processing. Okay. Next, what does it mean? To find the root word or base word for noun and verb using vibhakti for noun and suffix for verb. Okay. The meaning is, the exact meaning is to find the root word or base word. Okay. So how to find the root word or how to find the base word of a particular word? That word may be a noun, or that word may be a verb, that word may be adverb, that word may be a adjective. So here I have taken two examples, one for noun and another for verb. Okay. Now, so from the noun, how we find the exact root word of a particular noun? That means using vibhakti. From the vibhakti, we can easily find out the exact or the root word of a particular word. But in case of verb, how we find? We found in case of verb, we found from the suffix. For example, going, ing. The last three characters is ing. Now, suppose booked, booked, ed. Last is ed. From the suffix, that means from the suffix, we can find the exact root word of a particular verb. That means reducing the character from right to left. That is the method. That is a technique. So reducing some characters or alphabets from a particular word. Suppose I am taking a word that is called book, booked. Last you reduce it. That means first D will be reduced, then E will be reduced, then we get the word is book. So this is my root word or this is my base word. But how to reduce this? You have to use some algorithm. That is, if you go for any suffix prefix algorithm, then only you are able to find the root word. Okay. Next is analysis. What to analyze? What to analyze about a particular word? You have to analyze the gender. You have to analyze the number. You have to analyze the infection. You have to analyze the tense of a particular word. Then only that is called your morphological analysis. Morphology means word formation and the structure of a particular word. Next terminology is morphemes. What is morphemes? A smallest meaning, a smallest unit in the grammar of a language is called morphemes. Or you can say a smallest linguistic unit that has semantic meaning. Yes, there is a semantic meaning. Okay. In other words, you can say a smallest part of the word that can carry a discrete meaning, semantic meaning or a discrete meaning, whatever may be. Then you can say this is called morpheme. And these are some examples that of the different types of morphemes. Or you can say minimal meaningful language unit. That is basically unit. What exactly the unit is? Now, if you see the examples, I think all of you are able to see the example. Here I am going to highlight this one. Now, unbreakable. The last word is unbreakable. Now, un is one morpheme, break is one morpheme, able is one morpheme. There are three morphemes are there. That is, if you merge three morphemes, then it becomes a meaningful word. Unbreakable, just like this: incoming, outgoing, unhappy, on and happy, happily, happy and lee. Lee is the happy one morpheme, and ly is another morpheme. Okay, now unhappiness, on is one morpheme, happy is another morpheme, and the ness, ness is another morpheme. So this is all about your morphological analysis and morphology and morphemes. Next we move to types of morphemes for English language. Now different types of morphemes are there. Free morphemes, bound morphemes, inflection morpheme, derivational morpheme, root morpheme, null morpheme. Different types. I'm not going into the details about the morpheme. This is very general things or common things are there. Different types of morpheme. Next, I move to morphology for English. Now you see different types of pronoun morphology. Okay, study of grammatical classification of pronoun. How to classify? That is very, very important. Now, what to classify? The pronoun, how to classify, or the noun, how to classify. Pronoun morphology. What is actually the pronoun? I is one pronoun. You, he, they, it, they are pronoun. But what is pronoun? But how you distinguish that this is called your pronoun morphology. The study of the grammatical classification of a pronoun. That means you, that is used in a second person plural form. You, sometimes it is used singular, sometimes it is used plural. But in case of he, that is used in third person. Everyone know that the he is used as the third person, but they use as a third person, but in plural. So if you input, it becomes a third person. But whether it is first person or whether it is in plural form or in singular form, if you enter he, then it is recognized as a singular form. If you input they, it will be recognized as a plural form. But that is the work of morphology. That is the work of morphology. That means that is the assignment or job of morphology. Morphology actually distinguishes or identifies what type of morphemes are there, what type of grammatical structures are there in a particular word. Next is inflectional morphology. What does it mean? Combination of root word with grammatical morphemes. That means it will display the entire grammatical structure of a particular morpheme. That means present tense, first person, singular or plural form, or in second inflectional singular, or first there are different types of inflectional forms are there. Okay, first inflectional form, second inflectional, third, fourth, like this. Now if I have taken one example, dogs and cats. Now S is the suffix over here. Now S is attached to dog. Now what is the, if I say dog, you can say it is the third person, and dog, only dog, dog, that that means it is singular form. But if there is S over, if there is S, that you can say it is in plural form, just like this, cat. If I say cat, it is in singular form, third person singular form. But if it is connected to S, or S is attached to cat, then you say that is in plural form. Okay. Now this is all about your pronoun morphology and inflectional morphology. Next we move to derivational morphology. This is very important. Derivational morphology. Okay. Now this is a combination of word stem. Let us see what is stem. Okay. Let us discuss what is stem with grammatical morphemes with different classes. What are the different classes? Let us see. Okay. Now combination of word stem. What is stem? Now see. Derivational morphology. Let us discuss with derivational. It derives something. Derivational means it derives something. Okay. So now you see here is from the example it will be better understand. So beauty and beautiful. Now you see beauty. If you use beauty, that is in noun. If you attach full with beauty, then it becomes an adjective. Now this is the derivational form of beauty. Okay. Beauty sometimes beautiful. How it will be beautiful? How it is beautiful? If you attach the suffix ful, then it becomes adjective. Now converted to adjective. In the second form, you see in the second example, sing, SING, that is in verb form. If you use the suffix er, that means it become noun. Now verb become noun, in noun become adjective. So this is called derivational morphology. Okay. Now you derive something. So the beautiful, the adjective derived from noun, the noun derived from verb over here. Now you see. So this is called derivational morphology. Now we go for stem and lemma. What do we mean by stem and lemma? We already discussed about the morphology. What is the meaning of morphology? It will display the entire grammatical structure of a particular word as well as the root word and the base word. Okay. This is the definition of morphology. Next we go for stem. Now, yes, what is stem? A stem is root or roots of a word. That is also a base word or root word. Okay. Now, in case of lemma, that is also a base form of a particular word or root word. Now, what is the difference between morphology, stem and lemma? Let us see. What is the difference? I am saying that morphology means to find the root word or base word with grammatical structure of a particular word. But in case of stem, it will also find the root word or base word of a particular word, but it will not show you any grammatical structure of a particular word. In case of lemma, same thing. Base word. It will also display the root word and root word or base word or base form of a particular word. Thus, what is the difference between morphology, stem and lemma? Let us see. Now, there is an example. What is the difference? You just find out. Just take the word produced. Produce, D-U-C-E. You, all of you, just mark it. Whatever examples I am given over here. Okay. Now, all of you, please mark it. Produced, produce, production. 3 words are there. Okay. And the last word, you see, all of you, the last word is, sorry. The last word is produce. Okay. Now, produce, it is in the verb form, that means in the past tense. Produce, D-U-C-E. This is the root word. Production is the lemma. Lemma means the root word. The root word is production. Now, the stem is produced, P-R-O-D-U-C. From this C, just a minute, 1 minute. Okay, I will show you. P-R-O-D, just I highlighted this, all of you see, D-U-C. After C, there is a variation, all of you mark it. After C, D, you see, there is a variation. You just see. You just see over here. See, after C, T is there. But in case after C, E is there. But in this case also, after C, E is there. That means ED. In this case, only E. And in this case, production after C, T is there. Where the variation starts? The variation starts from after C. Okay, all of you clear? So now the stem form is C. But if you find the stem of a particular word, you cannot get the exact meaning of that word. Okay. Now see, produce, P-R-O-D-U-C. Is there any meaning? No meaning. But produce, yes, there is a meaning. This is called lemma. This is called lemma. But in case of stem, there is no meaning. Now, you just mark the variation, where the variation starts. After C, there is actually variation is started over there. Okay. Now, another example, compound. All of you see the word compound, compute and compute. Now, what is actually lemma and what is actually the stem? Now, and you see another example, computing also. Okay, computing. Now, after T, the variation is after T, the variation starts. Now, in this case, in the second case, now after T, E is there, but in this case also E is there. Now, in this case, the last example, A is there. Computation, A is there. That means variation starts after T. Now here, you just fill the difference. After T, there is E. So what is the exact stem and exact lemma? Okay, the lemma is stem, compute, C-O-M-P-U-T. Only up to T, that is called stem. But the lemma is compute, P-U-T-E. There is a meaning of this word. But in case of stem, there is no meaning. But in case of morphology, it will also show the root word. It will also show you the root word, but as well as or along with the grammatical structure. But in case of stem and lemma, it will not show the grammatical structure. Only morphology, it will show the entire grammatical structure. That means the number, person, gender, tense, everything it will show. But in case of stem and lemma, it will not show you anything. It will show you the root word or the base word. Okay. So this is all about your morphology, stem and lemma. Next is the mathematical. In the mathematical, how it will be treated as a mathematical. That is called your morphological analysis. That is morphological analysis. The equation of morphological analysis. It is a surface form of the word. Morphology. That means base form. May be obtained from morphological analysis itself. Next is mapping from every element of lexicon to all possible root words. That is the equation. All possible roots, along with all possible lexical information. What do you mean by lexical information? Lexical information in the sense of gender and tense and number, everything it will show. And that is the mathematical formula, or you can say mathematical equation of the morphological analysis. This L stands for lexicon and R stands for the root dictionary. I have to prepare a dictionary. Actually, whenever you go for morphological analyzer or developing any morphological analyzer, you have to first prepare a root dictionary. That means root word dictionary. What it contains? It contains set of all valid root words in any language, either Hindi, English, Odia, Tamil, Telugu. First, you have to develop a root dictionary. Then I stands for what? The set of all possible lexical information. I stands for actually information. That means noun, verb, adverb, adjective, gender, number, person, everything, every information. This is called lexical information. Okay. Next, we move to part of speech taking. This is a part of natural language processing. Part of speech. Everybody have done in the school level part of speech of any sentence, English sentence or Hindi sentence, Odia sentence, Bengali, Tamil, any sentence, part of speech. So what exactly the part of speech? And the tagging is what? Tagging means annotation. Tagging means labeling. What to label? What to annotate? The word to be annotated. The word to be labeled. How to label? You need a particular algorithm. Any algorithm. So first you have to judge what type of problem is the part of speech problem is. That is basically a classification problem. If it is a classification problem, so we need a classification algorithm, classification best algorithm, whatever algorithm available in machine learning. Okay, let us see how part of speech tagging is done. Basically, it's a part of natural language processing. Now, what is the meaning of part of speech? Annotate each word in a sentence with part of speech marker. Part of speech means whether that word is noun, whether that word is verb, whether that word is pronoun, whether that word is adverb or preposition, that you have to annotate, you have to label. Okay, each and every word. Suppose I am giving one example in English. I am going to school. Now, what is I? I is used as a noun. I am. What is am? You can say that is an helping verb. I can say I am going. Going. What is going? That is a main verb in ing form. Going to. To means what? That is preposition. Going to school. School is used as a noun. So, how machine will do this? How machine will annotate this? How machine will label this? Okay. As a human being, we can do this. No problem. As a human being, because I read the grammar of English. Okay, English grammar already we have learned, so we can easily annotate. So how that type of annotate can machine do? Okay, is it possible to do the machine in case of machine? Yes, it is possible using some machine learning algorithm. Just let us see what type of algorithm I have used over here. Okay, just now another thing is to identify the grammatical meaning of each and every word in a sentence. Identify the grammatical meaning of each and every word. That means noun, verb, adjective, that we have to find. Each word in a sentence with suitable tag. We have to tag it, we have to annotate it. Okay, so from a given tag set. Now, tag set is there. What is tag set? Now, we need a tag set, or you can say set of tags. But actually, I have done I have developed a software that is based on Odia post tagger, based on Sarala Mahabharata corpus. Okay, so whenever we develop this type of tools or software, we need set of tags. We need set of tag or tag set. So where I collected that tag set I had collected from Ravenshaw University Department of Odia, because my work was based on Odia. Okay. So anyway, so whenever you go for tagging, you have to collect some tag set. Okay. In your language, in your corresponding language, any language, either Hindi, Bengali, Tamil. If you go for any language, then first you have to collect the tag set. Then only you go for the tagging. Okay, part of speech tagging. Now, what are the classification? What are the different types of classification used in part of speech tagging? Support vector machine, artificial neural network, maximum entropy, conditional random field, and the hidden Markov model with Viterbi algorithm. Here I have taken one example purely based on hidden Markov model with Viterbi algorithm. Okay, that I will show you later. Okay, but this is the actual definition of part of speech tagging. Now another thing is features of language. You have to find out the exact features of a particular language. If you work for English, if you work for Hindi, if you work for Bengali, Tamil, Telugu, then you have to find the exact features of that particular language. That is the main problem of a particular, to finding the features of a language. That you have to study thoroughly of a particular language. Then only you are able to find the features of the language. Okay. Next is finding the root word using morphological analysis. That is one of the part of speech tagging. Now, what to identify or what to annotate or what to label? That each and every word should be labeled as verb, noun, adjective, pronoun, adverb, preposition. Here, I have taken one example. I will go to home by bus. Now, if you go for tagging, so how to tag it? The first I will be as a pronoun will. used as, sorry, okay, will, that is helping verb, and go is the main verb. To is the preposition. Home is used as a noun. By is used as a preposition. And finally, the last word, was is used as a noun. But as a human being, we can do this. Very easily we can do this. But how machine will do this? There is a problem. Okay. So this is a challenging task. How machine will do this? How machine will tag this? Suppose I am giving one particular sentence to as an input. So after tagging, after doing the tagging, after tagging, that is done by the machine. So what is the tag? What is the tagged sentence? Okay, what is the text sentence? Okay, using machine learning algorithm. Okay, any machine learning algorithm, because part of speech tagging is a classification problem. So you have to use any classification problem, whatever classification problem is fit for your tagging, for your part of speech tagging. So I have used hidden markup model with Viterbi algorithm. Just I will show you. Okay, next. So these are the various terminology used in English language. So noun, adjective, verb, conjunction, and pronoun, adverb. First, what we will do? We go for, okay, part of speech tagging. Basically, so my topic is actually a natural language text analysis, and what we can say that text analysis, and the thing is that processing. Okay, now analysis part is over. Analysis part is over. Now I already moved to our what we can say that is the processing part. Okay, now processing part is already started.
Hello. Dear participants, there is some technical glitch at Dr. Vishwaranjan's side. So he's joining us in 2 minutes. Please cooperate with us.
Sir, am I audible? Am I audible?
Yes, sir.
Okay, okay. Sorry, sorry. I am extremely sorry due to some technical
No
problem.
issues, no so issues, sir.
So next we move to, so this is now my slide is sir visible. Just to confirm it. Slide is visible. Okay. Next, so whenever we go for part of speech tagging or part of speech tagging, then what we need actually? Then we need training and test data. Next is suffix and prefix. Next, lexicon, coordinate, machine learning algorithm. What basically we need? Training and test data. Suffix and prefix also we need whenever we go for part of speech tagging. Then lexicon also we need, but this is not mandatory. Lexicon and coordinate is not mandatory, but mandatory is what? Training and test data and machine learning algorithm. Okay, for part of speech tagging. Next is features. What are the features available? Okay. Affixes includes prefix and suffix. Prefix and suffix of a particular word that brings is called affixes. Affixes is the last number of characters or number of alphabets from left to right or right to right. For example, on happiness, on is the suffix, on the prefix. Happy, which is you can say infix, and the suffix is what? On happiness, NESS, that is suffix, you can say. Now, if you see, this is basically the Odia features of the Odia language. You forget about this. Now, if you go for IMG, ED, NESS, on, cool, this is basically used as a suffix or prefix for English language. Now, to find to root word or base word for noun and verb using vibhakti and suffix. Using vibhakti and suffix. This is very, very important to find the features of a particular English word. For example, noun and verb. Okay, next. There are different approaches for part of speech tagging. What are the different approaches? First one is rule-based approach. Second one is the statistical or probabilistic based approach for part of speech tagging. And the last one is hybrid. Hybrid approach means the combination of statistical and probabilistic approach, best approach. It's called hybrid approach. So I focus here only statistical or probabilistic based approach. Oh, fine. Next, move to, so what we need for tagging? Training set, test data, training data, test data, machine learning algorithm, and prefix and suffix. This is the this we need for part of speech tagging. And here is I am showing one flowchart for part of speech tagging. So first, what you have to do? If you go for rule-based approach, then first you have to enter a particular string or sentence. Either it is in Odia. I have written over here Odia. Sorry, this is not actually the any text you can input over here. Not only the Odia text. It can be English, Hindi, Bengali, Tamil, Telugu, any text. Okay. Next you go for tokenization. Next you go for root word finding. So this root word finding is attached to the lexicon. Basically, lexicon is a dictionary. Whether that root word is present in that particular dictionary or not. If it is present, then it will so far so good. You can easily take the particular word. Next, otherwise not. Next, finally we get the part of speech of a particular word. This flowchart is based on the rule-based approach, not statistical, not probabilistic, or not hybrid approach. This is purely based on the rule-based approach. But rule-based approach is not good for the part of speech tagging. As I done this, as I have already get the knowledge through practical. Okay. Next is algorithm for, this is the basic algorithm for the rule-based approach. Okay. Now, next we move to the statistical or probabilistic approach. Very, very important. Okay. Now you see how the probabilistic approach work for part of speech tagging. Okay. Now you see, this is purely practical based, purely practical oriented. Okay. Now here I have taken 4 sentences as a training set. Now the sentences are Mary, Jane, can, see, will. Spot will see Mary. Will Jan spot Mary? Mary will pat Spot. Now you just follow four sentences. Mary Jane can see will. Now, what is the form? Now, in which form? First, Mary is in the form of noun. Next, Jane in the form of noun. Next, can is the form of modal. Next, see is verb. Next is noun, will. The noun. The last word is used as a noun. But in the second sentence, all of you see, Spot will see Mary. Now, will is used over here as a modal, but will is used here as a noun. Okay. Now, in the third sentence, will is used. Will is used as a modal. Now, if you see the spot over here, spot is used as a verb in third sentence, but in the last sentence, spot used as a noun. But this is a very confusing thing in case of machine. Okay, human being can do this. Okay, fine. Human being can do this. That means human being can do the proper tag of this particular sentence. But how machine will do this? Very confusion. This is very ambiguous. Very ambiguous for machine. Okay. Will is used as a verb. Will is used as a noun. So how machine will find the exact meaning of the will or spot? Okay. So actually this is my training set. This is my training set, and the last sentence is test set. Okay. What is test set? Will can spot Mary. Let us see how the system will doing the tagging over here. Okay. Now I already got what is will? Will is used as a noun as well as the modal. But in this case, whether will used as a modal or used as a noun. Okay. Now in this case also, spot in the training set, spot is used as a noun and spot is used as a verb. But in the test set, what is the actual tag of the spot? Okay. How machine will do this? Because in this case, in the last sentence, in the last training set, spot is used as noun. In the third sentence, spot is used as a verb. But in the test set, what machine will do? What machine will tag? Whether it will tag as a noun or whether it is tag as a verb. That is a very, very, very challenging task in case of part of speech. Let us see how machine will do this. Okay, fine. Now, the next slide is moving to next slide. This is purely based on statistical or stochastic or probabilistic based approach. I have that already told you before. Okay, now I apply here hidden Markov model using Viterbi algorithm. Okay, for part of speech tagging. Okay, now there are two probability metrics. One is transitional probability, another is emission probability. Now, John can see will. Okay, John can see will. This is an example. John is used as a noun in case of emission probability. Can is used as a modal. See is used as a verb. Will is used as a noun. Okay, now the transition probability is what? One after another. One after another means n is one state, m is another state, v is another state, and n is another state. Now we are moving n to m, then moving to v, then moving to noun. This is your tag sequence. This is called your tag sequence. Now the emission is what? John is detected as noun, Ken is detected as modal, C is detected as verb, will is detected as noun. Now, our examples in training set already given. Okay. Now you see, these are the four sentences that I have used. This is first sentence, and the tag sentence is this. Now, another tag, additional tags I have used. First, S stands for start and E stands for end. I have used that additional tag over here. Why I used? Let us see. Okay, बाद में देखेंगे. Why I used this? Next is spot will see Mary. Spot is used as a noun, then will is used as a modal. In the second sentence, see is used as a verb, and Mary is used as a noun, and the last is and means either full stop, and E means full stop, and this is the start symbol. Okay, the first. Now, will Jen spot Mary? What is the text sequence? The text sequence is M N V N. I forget over here. S is one. S is there. Okay. S. Okay. S and E. Okay. Now, S is the start symbol and E is the end symbol. Now, Mary will spot. This is the text sequence. This is also text sequence, and S is here, and S is here, and that I forget. Okay. Now, see, noun, modal, verb. Now, this is called text sequence of this particular sentence. This is the text sequence of this particular third sentence. This is the text sequence of this particular second sentence. This is the text sequence of this particular first sentence. So this is my training set. This is my training set, and my test set is what? Will can spot Mary. So, what is the exact grammatical or lexical information of will? Will is used as noun, can is used as modal, spot is used as verb, and Mary is used as noun. Let us see whether machine is giving this type of output, this type of correct output or not. Okay, let's see. Now, Mary, Jane, Spot, and Will, four all names, English names. Okay. Next, we move to emission probability. How to find? There are two probabilities. I have already told in the previous slide. We have to find emission probability and the transition probability. Through this emission and transition probability, we find the exact text of a particular sentence. That sentence is will can Mary, will can spot Mary. Okay. Now, finding the emission probability. Oh, counting table. This is the table. This is in the form of matrix. How many times Mary appear as noun, modal, and verb in the training set? Now you see, all of you, how many times Mary is used as a noun, modal, and verb? How many times? If Mary is used as noun 4 times, Mary is used modal as 0 times. That means no modal for Mary, and Mary is how many times Mary appears as verb? How many times? 0 times. That means Mary only appear as noun. Okay, like this. Jane, how many times as noun? How many times as modal? And how many times as verb? 2, 0, 0. That means Jane used or appear in the training set 2 times as noun, but 0 times as modal and 0 times as verb. Like this, will, spot, can, see, and pet. This is the counting table, basically. Oh, next we move to next slide. Now, let us divide each column by the total number of their appearance. For example, noun appear 9 times. If you count how many nouns are there in this case, in my training set, there are 9 times. 9 total number of noun is 9 in this case, in my training set. Okay. Now, so this is all about your counting table. Next we move to this. Okay. Now, for example, noun appears 9 times in the above sentence. So divide each term by 9 in the noun column. Now you see, noun column, that is 4 divided by noun. 4 divided by 9. That means Mary appear 4 times out of 9, 4 times as a noun out of 9 nouns. Okay. Now Jen appears as a noun 2 times out of 9 nouns. Just like this. Will, how many times? 1 time. Spot, 2 times. Now Mary appears how many times as a modal? 0 times. Mary, how many times appear as a verb? 0 times. Just like this. So this is called your emission probability. This is I find the emission probability of the particular 4 sentences, whatever sentences in the training set. That in the training set I have taken 4 sentences only. But this is the emission probability that I find from the training set. Okay. Now from the above table we infer that The probability that Mary is noun equals to 4 by noun. 4 by 9. Now you see, Mary appears 4 times as a noun out of 9 nouns. Total number of nouns. This 9 is total number of nouns present in the training set. And 4 means the Mary 4 times appear as a noun in the training set. Okay, just like this. Mary is probability that Mary is modal 0 times, probability that will is noun 1 times, probability of will is modal 3 times out of 4. Okay, so this is all about your emission probability. Next, we go for transition probability. Transition probability in the sense what? Transition means what? Transit from one state to another state. Now, first, Mary, you see, all of you, actually the sentence. What are the sentence inside my training set? There are 4 sentences. This is my first sentence. This is my second sentence. This is my third sentence, and this is my 4th sentence. I just mark through pointer. All of you mark it. Mary Jane can see will. Noun modal. Can is used as a modal. See is used as a verb. Will is used as a noun. Now E, S and E. This S and E. This S is a start symbol and E is the end symbol of the sentence. Now next sentence is what? Spot will see Mary. So in which form? That is, if you go for a transition probability, noun, then modal, then verb, then noun. That means noun followed by M followed by V followed by N. Just like this. In this case, in the third sentence, M followed by noun followed by V followed by noun. Next, in the last sentence, N followed by M followed by V, and V followed by N. This is basically my transition probability. That means transit from one node to another node. That means that is basically a tag sequence. You can say that is basically a tag sequence. Okay. The next slide. Moving to next slide. Creating a table and fill it with co-occurrence count of the text. Now again we find the co-occurrence counts of the text. Now you see. So start now in the above figure. Now this is my figure. This is my table. S tag is followed by noun tag 3 times. S tag is followed by noun. S tag. Now this is S tag. This S tag is followed by noun 3 times. S tag is followed by modal 1 time. S tag is followed by verb 0 times, and S is followed by E 0. But how I get this value? Let us see. Now just showing the previous slide. Now S is followed by noun. This is 1 time. S is followed by noun 2 times. S is followed by noun 3 times. Yeah, 3 times. So this is 3. S is followed by noun. This is 3. Now S is followed by modal. Let us see. S is followed by modal. S is followed by modal. S is followed by modal. How many times S is followed by modal? Only 1 time in this case. In the third sentence, all of you see. In the third sentence, S is followed by modal is 1 times. Now this is 1. S is followed by verb. S is followed by verb 0 times. That means there is no S is followed by here verb. There is no verb over here. So that's why it is 0. It is 0. So S is followed by E. S is followed by E. This is 0. Now you see the previous. S is followed by E. Yes, there is no E over here. Only noun and modal is here. So that's why it is 0. So accordingly, you have to find the co-occurrence counts of the text up here. Next, we divide each dot in a row of the table by the total number of co-occurrence of the tag in consideration. For example, the modal tag is followed by any other tag 4 times as shown below. Let us see. Okay, how it is happening. Now you see. Modal tag is followed by verb. How many times it is present in my training set? This is first time, this is second time, this is third time, and this is 4 times it is appear in my training set. So that's why it is called. That's why it is 4 times. That means it is 4 times present. That means here we see. Oh, sorry. It is not like this. 1 minute. Okay, now you see. So the S followed by noun, S followed by M, and S followed by V, and S followed by E. How many? 3 by 4. S followed by noun 3 times. Now you see 3 times. S followed by noun, that is 3 by 4. S followed by modal. S followed by modal 1 times. Now this is 3 times. 1, 2, 3. This is 3 times. Okay. Now S followed by verb, that is 0 times. There is no verb over here. Now S followed by E, that is 0 times. Next is N followed by noun. Followed by noun. How many times? That you can see N followed by noun. Only 1 times it is present. Only 1 times it is present. So these are the respective transition probability value for the above sentence. Now how does the HMM determine the appropriate sequence of text for a particular sentence from the table? Okay, let us find out it. Okay, now see. So the thing is that these are the respective transition probability. I have already found this respective probability, transition probability for the above sentence. Now how does HMM work with this probability value? Now let us see. Okay, now in the next slide, take a new sentence as a test set and tag it wrongly. Okay. Now what is my test set? Will can spot Mary. Will can spot Mary. Now the actual tag of this test set is I already given here. I already show you here. Now you see this is Will can spot Mary. Here the example is Will can spot Mary as I have taken as a test set. I have taken Will can spot Mary. I have taken as a test set. But what is the correct tag of this sentence? The correct tag of this sentence is is this. First is noun. Will is used as a noun. Can is used as a modal. Spot is used as a verb, and Mary is used as a noun. Okay, this is my actual tag. But how actually whether this tag whether system is giving this type of tagging or not? Okay, let us see using HMM model. Okay, so move to the our slide. The slide part, it is saying that in this slide Will can spot Mary. Now you just take it wrongly. Why you take it wrongly? We test the machine whether it is giving the correct tag or not. Okay. Now will is used modal, can is used verb, spot is used noun, and Mary is used noun. That is a wrong text. That I made it. Okay. Now will as modal, can as verb, spot as noun, Mary as noun. Okay. Now calculate the probability of this sequence MVNN being correct in the following manner. Oh, let us see. Now, just see. The sequence is MVNN. Now, see. This is start symbol. This is end symbol. MVNN. We are finding? We are finding the probability value of this particular sentence using emission probability and using transition probability. Oh, start symbol to M, the probability value that we have already calculated, that is 1 by 4. Moving M to V, the probability, that means transition probability value is 3 by 4, and the moving from verb to noun V to N, the probability value is 1, and moving from N to N, that means noun to noun, the probability value is 1 by noun, that we have already calculated through transition probability. Now S to M, M to V, V to N, N to N, and N to E. Now go to the transition table, transition probability table. Here the transition probability, not this, the transition probability. Here the transition probability. Here the transition. Sorry, this is emission probability, and where is this emission probability, and where is the transition probability? Just 1 minute. Here the transition probability. Okay. Now actually the reading start symbol followed by M, that is 1 by 4. Start symbol followed by M. Now, start symbol followed by M. Start symbol followed by M. This is 1 by 4. This is 1 by 4. That we have already calculated. This is 1 by 4. Let us see over here. Okay. This is the transition probability that we have already calculated. That I marked in red ink. Okay. Next is M to V. M to V. That means M followed by V. M to V. M followed by V. M followed by V. 3 by 4. Yeah, 3 by 4. M followed by V. That is 3 by 4. That is 3 by 4. Now, M followed by V. That is 3 by 4. V followed by N. V followed by N. V followed by N. Let us see. V here, the last. V followed by what actually the V followed by N. V followed by N. V followed by N. This is 4 by 4. 4 by 4 means the value is 1. 4 by 4 means the value is 1. Now 4 by 4. Let us see. This is for 1. Next is N followed by N. N followed by N. N followed by N. Let us see in the transition probability. What is the value? N followed by N. Here. N followed by N. 1 by 9. Here. We have already calculated. Here 1 by 9. Okay. Next 1 by 9. This is sorry. Let us see. One minute. N followed by sorry. N followed by N. Yes. 1 by 9. N followed by E. N followed by E. N followed by E. Now you see. N followed by N. N followed by N. N followed by N. That is 1 by 9. Next is the last transition. N followed by E. 4 by 9. Here 4 by 9. How this value is 4 by 9? From the transition probability we get 4 by 9. Here 4 by 9. 9 followed by E. That means E. That is 4 by 9. Okay. Accordingly we just calculate the transition probability value. Next we go for emission probability. Emission probability. Wheel is model, and I have already treated as wheel is model and can is verb. Wrongly that we tagged it. Okay, we assume that. Okay. Now wheel is used as a model, can is used as a verb, spot is used as a noun, Mary is used as a noun. Now here the probability value can is used as a verb. 0. The probability value is 0. The probability value is 0. Now this is the emission probability. Now how we get, if you ask me, sir, how you get the value 3 by 4, 0, 2 by 9, 4 by 9 from the emission probability. Now from the emission probability wheel is appear as a model from the that value is 3 by 4 that we already found that in the emission probability. Okay, emission probability. Now we go to the emission probability. Okay, this is not the emission. Oh, now this is emission probability. Now Mary is used as a noun 4 by 9. Now you see. Now in the slide 27. Now we go to move to the another slide. So okay, just I am saying that 3 by 4 will 3 by 4 can 0. Can is used as a verb. Can is used as a verb. No. Can is used as a verb. Watch. Can is used. Can and verb. You see. Hey, 0. This value is 0. This value is 0. Can is used. Now there are 4 value. Mary is used as a noun 4 by 9. Mary and will is used as a modal 3 by 4. And spot is used as a noun 2 by 9. And can is used as a verb 0 times. Now go to our test set. What is the test? What is the step? Now you see. This is 3 by 4, 0, 2 by 9, and 4 by 9. So this is my emission probability. Now we have already calculated the transition probability as well as emission probability of this particular sentence. Wheel can spot Mary. Okay. The probability of tag model comes after the S is 1 by 4. This 1 by 4. The probability of tag model, this is tag model, comes after the S. As seen in the table. Also the probability that word wheel is a model is 3 by 4. Next, in the same manner, we calculate each and every probability in the graph. Now, the product of this probability is a likelihood estimation that this sequence is right since the tags are not correct. The product is 0. Now, see the product. What is the product? the first product 1 by 4 into 3 by 4, the transition probability into emission probability into again transition probability into emission probability. Now in this case you see the emission probability is 0, so total product is 0. That means it is that sentence is tagged wrongly. So how you know that that sentence is tagged wrongly? Because the probability value gives 0. If the probability value gives 0, that means you confirm that that is a wrong. That is wrong. The sentence is tagged wrongly. That sentence is tagged wrong. If you get any probability value rather than 0, then there is a possibility of correct tagging. Okay. Next, we move to next slide. Okay. When these words are correctly tagged, okay, I mean we go for tagging. We just make it a correct tag. Make it a correct tag. We get a probability value greater than 0. Now see the probability value. Now in the previous slide I tagged it wrongly, but in this slide I tagged it correctly. But how you know that whether the first tag is incorrect and the second tag is correct? According to the probability value. If the probability value is 0, that means this sentence, the entire sentence is tagged incorrectly. If you find the probability value rather than 0 or any positive number, any positive value, then the sentence is tagged correct. Okay, this is the basic thing. Next. So when these words are correctly tagged, we get a probability greater than 0 as shown below. Now here all of you see the probability value greater than 0. That means this sentence can spot Mary tagged correctly, labeled correctly, annotated correct. Okay, because of this problem, from this probability value we know. Now will appear as noun, can appear as modal, spot appear as verb, Mary appear as noun. So here is, you see all of you, here is also where the value I get this value from the transition probability table and emission probability table. This is actually emission probability, and this thing, this is the actually transition probability. This is actually the transition probability. Next, very important thing for this example, we can spot Mary. Our basic objective is to tag it correctly. So how many possible tags can be appear? Okay, now how many tags, total number of tags are there? 3 tags are there. One is noun tag, another is modal tag, another is verb. How many words in this sentence? There are 4 words. That means the possible combination of text, how it is calculated? 3 to the power 4, because total number of tag is 3 and total number of word is 4. So 3 to the power 4. That means 3 to the power 4. That is 81 combination seem to be achievable. 81. Can you imagine this? It's a very simple sentence. 81. If you take very large corpus, very large sentence, it will be very huge amount of combination of this graph. Okay, this is my graph. So will can be noun, will can be modal, and will can be verb. Now can be noun, can be modal, can be verb. There is a chance. Okay, from our example, keeping into consider just 3 pause tags, we have mentioned 81 different combination of text. 81 combination of text. Now this from this graph. Okay, very critical thing, very challenging things. Okay, next, moving to the next slide. Next step is to delete all vertices and edges with probability 0. Now 81 combination, those who are belongs to 0, you just delete this node as well as the edge. Delete the edge and node that I show over here. Okay. as with probability 0. Now, if you mark over here is a 0 probability, here is 0 probability, here is 0 probability, here is 0 probability, that here is 0 probability, and also here is 0 probability. That we have already calculated in the transition probability or transition probability. Okay. Next is to delete all vertices and edges with probability 0. Also, the vertices which do not lead to the endpoint are removed. Also, we will mention or remain the thing like this. The 81 combination become converted to this. Okay, 81 combination. Now we'll see. We can spot Mary. Okay, now 0 probability. We already we have already deleted or removed the 0 probability value. Now the graph looks like this. Now S, start from S. Will is used as a noun. Is may be noun. Can may be modal. Spot can be noun or spot can be verb. Here is a confusion. Here is the ambiguity. Ambiguity is where in this position the ambiguity arises. In this position the ambiguity arises whether spot is used as a noun or verb. Very interesting. Oh, now can, okay, we get this. Can is used as a modal, will is used as a noun, Mary is used as a noun. But all of you see spot is used as noun as well as verb. Which one is more correct? Whether spot is noun, is used as a noun, or whether spot is text. Let us see. Okay. Now I have already given the probability value over here. That probability value we have already calculated. Where we have calculated? In the emission table or emission probability and transition probability. Now there are only two paths. There are only two paths that leads to end. Two paths. From the path S, noun to M to N, N to N, N to E. Another path is what? S to N, N to M, M to V, V to N, N to E. Okay, now this is the path. The first probability value is this 0.000050846754. This is the probability value of the first path. That means S N M N N E. This is first path. The first path, the probability value is this. The first one. 0.00000 zeros are there, 846754. And the next path, S noun M V N E. This is second path. The probability value is this. I just mark it in red ink. Very important. Okay. Now, which one is the you just find which one is the higher probability value? In the first path is giving the higher probability value, or in the second path giving the higher probability value? In the second path giving the higher probability value. That means what it indicate? It indicate in the second path. There are two paths. In the second path, S N M V. That means V. That means spot is used as verb. This is the most possibility. Okay. And Mary, then V, then Mary, then E. Then so which part we have to consider? The second part we have to consider. Why will you consider the second part? Because of the probability value, because of the higher probability value. That means spot is used. That means we confirm that spot is used as a verb. Now, will is used as noun, can is used as modal, and spot is used as verb instead of noun here. Not possible. Instead of noun. Spot is used only verb. Then Mary, then E. End of the sentence. Now we confirm that the second path to be considered. Now already tagged. The sentence will can spot Mary is tagged as noun, modal, verb, noun. But you have to ignore this. You have to ignore this one. Because why we ignore this one? Because we get the less probability value. less probability value in the sense, why you get less probability value? Because why you get less probability value? In the training set, spot is used many times as a verb. So that's why we get the higher probability value in the second part. Spot is used in our training set. Spot is used in our training set many times as verb, not noun. So that's why the second part is giving the higher probability value. So accordingly, our machine is trained. Accordingly, our machine is trained. How our machine is trained? From the training set, our machine is trained. Spot is used many times as verb. Okay, here. Now, next, the probability value of the second sequence is much higher, and hence the HMM hidden Markov model is going to tag each word in the sentence according to this sequence. What is the sequence? The sequence is S, N, M, V, N, E instead of these first part. Okay, next, moving to the next slide. Optimizing. Okay, optimizing HMM with Butterby algorithm. Briefly saying that what I am saying that our objective is what? Our objective was what? To find the best possible path sequence using the probability value. I have already found in this slide, I have already found the best possible path. The best possible path. It depends upon the higher probability value. That means, briefly, I said that to find the best possible path sequence, that means tag sequence using the probability value. That means the best path sequence, tag sequence is based on the probability value. Next, why I use Viterbi algorithm over here. The Viterbi algorithm is a dynamic programming algorithm for finding the most likely sequence of hidden state called Viterbi path that results in a sequence of observed events, especially in the context of the mark of information sources and hidden Markov model. It's basically a dynamic programming, and what it gives the likely sequence, the likelihood sequence of the hidden state. This is very, very important. Likely give, but in case of hidden Markov model, what it is showing, it will giving the two paths, but in case of Viterbi algorithm, it will optimize the path. That means, what to optimize? The path will be optimized. How it will be optimized? Through Viterbi algorithm, it will be optimized. That means it gives the likely sequence of the hidden state. Okay, next. Move. So I have already designed a model or developed a model that is called your part of speech tagger model. So how to calculate the measure, or how to calculate the performance, or how to measure the performance of a pass or of any part of speech tagger. How to calculate the performance? Okay, using confusion matrix, we calculate the performance of the tagger, part of speech tagger. If we have that, we have already developed using whatever sentences we have taken as a training set, and whatever sentence we have taken as a training set, test set. Okay. Now, how to calculate the performance of our watch tagger, whether it is working perfectly or not working perfectly? Using confusion matrix, we calculate the performance of our tagger, whether it is a Odia tagger, or whether it is a English tagger, or whether it is a Hindi tagger, or whether it is a Bengali tagger, or whether it is a Tamil, Telugu, or a Malayalam, any tagger. If you already develop how to calculate the performance. Anyway, confusion matrix. In confusion matrix, there are 4 parameters. One is true positive, true negative, and another is false positive, false negative. It is a very common formula. I am not going into details about this. Okay. So, what is TP? True positive. Correctly identified. Correctly identified means correctly identify the tag. That is done by machine. I am not doing. Only machine is doing. So, as machine is concerned, then the TP means the correct identified tag, and TN means the correctly rejected tags, and the FDP means incorrectly identified, and FN means incorrectly rejected. From this formula, we calculate the performance of a particular tagger. Okay. Next, So what is precision? What is recall? Precision means in case of part of speech tagging, or if you already develop a tagger, what is the meaning of precision? How many are correct from? How many are correct from whatever has been obtained? That means now our system, our model is already developed. Now we test it. How to test it? We are inputting some sentence, random sentence. Okay, random sentence we are inputting. From the inputted sentence, we are finding the precision. That means how many words are correct, actually tagged, how many words are not actually tagged. That we have to find out using precision and recall. How many are correct? That means corrected from whatever has been obtained by the machine, not a human being, by the machine. Next, recall means what? Of the correct ones, how many have been obtained? Of the correct ones, how many have been obtained? Of the actual, that means actually, what is the meaning of this? Of the actual correct text, how many have been obtained which are correct? That is called the recall. Okay. So using this formula, we can calculate the performance of a particular part of speech tagger if you have already developed. Otherwise, not. Next, what software we use basically to develop a part of speech tagger? Either you can go through Java or JDK 1.7, or you can use NetBeans onwards with JDK 1. Or you can develop through Python also. Python is more compatible with any Indian language. For any Indian language, better you go for Python. This is my best suggestion to all of you. If you are going for any language processing task or computational linguistics, then better you go for Python. Okay, next. This is the application area of part of speech tagger, or you can use part of speech tagging. Okay. If you have already developed a tagger, then you can use it. Where you can use it? In the machine translation, in the information retrieval, information extraction, word sense disambiguation, question answering, name entity recognition, sentiment analysis, opinion mining. These are the application area of part of speech tagger. You can apply over here. Whenever you develop a machine translation, you develop an information retrieval system, or information extraction system, or word sense disambiguation systems, or question answering system, or name entity recognition system, any system, then you can use your tagger over there. Finally, develop a stemmer. If you want to develop a stemmer, lemmatizer, or parser, any parser, not only ODI parser, any parser or analyzer, morphological analyzer, machine translator, even if you design a compiler also. Compiler is basically a language processor. Even if you even if you want to develop a compiler in your language, in your own language, in your own mother tongue, you can also develop a compiler. Either Hindi, English compilers, Hindi, English, Bengali, Tamil. Okay, finally you can develop a compiler because it's a language processor. Okay, so this is all about my part of speech. Next, move to parsing. What exactly the parsing is? Okay, now the parsing is the syntactic and semantic analysis of a particular sentence. Okay. Next, parsing is the process of determining how a string of terminals can be generated by grammar. Okay. Grammar means the production rule. Here the grammar means the production rule. Syntactic and semantic analysis of a sentence. Syntactic, the meaning analysis, and semantic analysis means the entire grammar analysis, grammatical analysis is called semantic analysis. Okay, in case of parsing, that parsing defined in three ways. As a literature people, what they have defined, what linguistic people, what they have defined, and in a mathematics expert or mathematics expert or mathematician, how they define the parser. In three different ways, parser is being defined. Okay, next. There are two types of parser. One is top-down parser, another is bottom-up parser. I think everybody knows this. Everyone knows these types of parsing. Okay. Next is the production rule. What is the production rule? This is my production rule. N will be converted into NP and VP. NP, noun phrase will be converted to noun. Noun phrase again converted to. These are the some grammatical rule, production rule that I have used. That you can also use this production rule if you go for any parsing. This is the examples of parsing. Sita reads a book. Sita reads a book. So basically, this is a parsing technique. This is a parsing technique using some production rule. These are the production rules. Next. These are the parser already developed. Top-down parser, bottom-up parser, CYK parser, dynamic programming parsing algorithm, early parser, different types of parsers are there. Okay, already developed. Probabilistic parser, dependency parser, early parser, okay, CYK parser already developed. Okay, next is another parsing is technique is constituency parsing. What the constituency parsing is? Constituent means the group of words. Constitute the group of words. Group of words that is called constituent. Break a text into subphrases. First, break any text or any sentence into subphrases, phrases or subphrases. Now, non-terminal in the tree are types of phrases, and terminal are the words. The last terminal node. This is the terminal node. This is the terminal node. These are the terminal nodes. Okay. Now, non-terminal in the trees are type of phrase. Non-terminal. This is one type of phrases. Noun phrases, verb phrases. Again, verb phrases divided into two parts. One is verb, another is noun. Now, Ram sees Sita. This is from Sita, from C onwards. This is verb phrase. And the noun phrase is what? Noun phrase becomes Ram. And this noun phrase converted to noun. Now, Ram is noun. According to the grammar, or production rule. Okay, now this is the dependency parsing. Why it is dependency parsing? Now the example is Ram see Sita. Ram is subject, C is taken as verb, and Sita is treated as an object. Now Ram and Sita both are depend on this verb. Both are depend on this verb. That means Ram sees. Who sees Sita? Ram sees. Okay, Ram sees Sita. Sita is object over here. Okay, Sita also depend on Ram. Okay, so that's why this is dependency parsing. Based on the karako is important for the parsing. Verb. Okay, verb. That is called verb. If you ask any question, that question will be based on verb. Ram, who will see? Ram will see. Who will see? Ram will see. Whom see? That is Sita. Okay. Now, the child node are depend on the parent node. These are the child node. What is the child node? The Ram and Sita are the child node. That child node is depend on the verb. That means this verb depend on the parent node. This parent node is called here verb. Verb node. The edges labeled by the relationship. What type of relationship? Is a relationship or has a relationship, but in this case is a relationship. Okay, now this is all about the dependency parsing. Next, traversal. Just like a parsing is in which form? This is in tree form. This is in tree form, but we have to traverse it. In which way we have to traverse it? In order traversing method, pre-order traversing method, post-order traversing method. There are three types of traversing method. First one is in order, pre-order, and post-order traversing. But the more accurate is in order traversing method. As per my practical knowledge, I am saying that only in order is the best traversing method for the parsing. Okay. Now in order. Now you go for in order. That means left, right. Best it gives the best result for making a sentence. That means SVO and SOV. SVO, subject, verb, object, and subject, object, verb. Suppose Ram sees Sita. Ram is the subject, sees is the verb, Sita is the object. But if you convert to SOV form in any Indian language, that becomes subject, object, and verb. The position of verb is going to the last, and the object is going to the middle, and the subject as well as. Okay. So this, if you go for tree traversal, then this is in order is the best method to traverse the entire tree. Okay. Next, here is some examples. Here is some English and Odia examples. I am not going details about this. I am going to home. This is in the I am going to. That is basically in subject, verb, object. Subject, who is the subject? I. Verb is what? That is going. I am going to home. That is verb. That is object. Sorry, object. That is of. Am going is the verb. It will be treated as a main verb with helping verb. But to whom, that is object. But if you translate this English sentence to either Hindi or Odia or Bengali or Tamil, it becomes SOV verb. So this is the structure, how it becomes SOV verb. How it becomes the SOV verb. Okay. Next we move to according to the formal language. According to the formal language, this is the examples of parsing. I have taken one mathematical equation, how it is parsed. So according to the precedence and associativity, we parsed the entire mathematical equation or mathematical expression. Okay. Next, we move to why parsing. What is the use of parsing? Why you go for parsing? Arrange to form meaningful sentence, phrase and clause. Arrange to form meaningful sentence. That means semantic is there. Meaningful. If you get a meaningful sentence, if we go for parsing. This can mean the selection of words put into a proper place of what? Tense. That is the use of parsing. Okay. Now derive the language sentence into small components. To divide the language sentences into small components, that is called your verb, noun, subject, object, etc. That can be analyzed using parsing. Divide the language sentence into small components. That means token, small token. Components means token. Then you go for analyzing parsing. To identify the type of each component, each token, it will be better if you go for parsing. Okay, to identify the type of each component or each, that means each token, whether that token or component is used as a verb or noun, adjective, subject, object, etc. And this is the basically rule for syntactic arrangement for Odia language in machine translation. You forget about this. Okay, this is the examples of Odia language. Now, basically, why we go for parsing? Basically, it is used for machine translation. If you translate from one language to another language, parsing is needed. But sometimes it is needed, not always it is needed. If you go for rule-based approach, then it is needed. If you go for statistical-based approach, parsing is not necessary. Because we have a lot of training data, lot of training corpus. The parsing is not required for machine translation if you go for statistical way, if you go for statistical method. Next is, now you see, in case of machine translation, what is happening? I am a boy, I have a pen. Now, I is used over here, may, and sometimes I is used mera. So how machine will identify whether I is used as man and whether may or whether I is used as mera? Because I am a boy and I have a pen. Now, the meaning of I is different over here. If you translate the meaning of I, whether it is may or mera, it is very, very difficult if you go for machine translation. Yes, it is. There is a solution. There is a solution. No doubt. There is a solution. How to find the solution? Using the lot of training data. Using the lot of training data, we can easily find that whether I is used as may or mera. How many times I is used as may or mera, that we easily know from the training set. How? From the probability value. From the probability value, we easily find how many times used I is used in training set, whether it is may or mera. Okay, that is the solution. Next, word alignment. For the machine translation, basically it is used word alignment. Okay. Now, word alignment means word mapping. Whenever you go for machine translation, we need two type parallel corpus for both language. So once you get the parallel corpus, after getting the parallel corpus, then you go for word alignment or word mapping. Okay. Then that means word mapping may be 1:1, 1:many, and many:1, and many and many and many. Okay. So that type of processing you have to do whenever you go for machine translation. And this is the most important thing of machine translation if you go for word alignment. If you go for machine translation, so you have to use word alignment. Okay. Next, all of you see. So these are the very ambiguous sentence. How machine will solve this? How, as a human being, you can solve this. I think, but in case of machine, how it will be solved? A mother, the first example, the first ambiguous sentence. Just I am showing over here. A mother beat her daughter because she was drunk. Who drunk? Whether the mother drunk or the daughter drunk. How you do this? If you go for tagging, how you have to find the exact meaning, exact sense of this particular sentence. Okay. The next sentence is, I saw a girl in the garden with a telescope. With a telescope, whether the girl holds the telescope or I hold the telescope, whether I see the girl through telescope or the girl holds the telescope. In hand, he may be holding the telescope. Okay. So, what telescope will represent? Whether I or girl? You cannot find it. You cannot find in a single statement. You cannot find the exact sense of this sentence. Ram killed Shyam in his car. In his car. His car means whether this represents, whether his represents Ram or whether his represents Shyam. Ram killed Shyam. Okay, fine. In his car. Whether in scene Shyam car or whether in Ram car. मुझे सोना अच्छा लगा. Sona means what? What is the meaning of ornament? Or sona, this is sleeping. In which sense it is used? Can you find the exact sense? Yes, we can find. We can find. But in a single sentence we cannot find. If you input a single sentence to the machine, मुझे सोना अच्छा लगा. Machine cannot find what is the meaning of sona. Whether sona is represented as sleeping or whether sona means ornaments, just like this. Yes, this is also, these are all ambiguous sentence, but we can find the exact sense also, exact meaning of this particular sentence. Next, can it be solved by machine learning algorithm or any deep learning algorithm? That means, can it be solved means these 3-4 sentences. There are so many ambiguous sentences. There are so many ambiguous sentences. So can it be solved by machine? Can it be solved by machine through machine learning algorithm or any deep? Yes, it is solved. Yes, it is solved. But in a single statement, we cannot solve it. We have to take huge amount of training corpus. We have to take huge amount of training corpus. From the training corpus, we can find the exact meaning of any particular sentence. Yes, it is possible. Okay, so this is all about my talk lecture. So now the session is for question answering. Okay, sir.
Thank you so much, sir, for a detailed talk on NLP. So, dear participants, if you have any queries, you can directly talk to our resource person, Shri Vishwaranjan Das ji.
Any question? Any question, please? Any question or any advice or any comments or any suggestion?
Few comments have been, sir. Please see the chat box.
Okay, okay, okay. Just sir, 1 minute. Okay, sir, please use F5 for sites to connect our more easy. That's okay. Very wonderful session. So, any other comments or advice or suggestion? Only few comments are presented very well.
It fixes rules. Fixes someone has written.
Nursing. I understood that all of you understand very well. Overall. Whether all of you understand or not understand. Any question or any comments or any suggestion?
So, if there are no questions, so I once again thank you, sir, for sparing your time. And that was a detailed talk on NLP. You have explained number of things. The number of things are new for the participants, and even in future also, we'll think to organize the sessions on NLP again.
Okay.
So I once again thank you so much for having a very insightful session on natural language processing. Thank you so much, sir.
Thank you. Thank you. Most welcome, sir. Most welcome. And thank you, everybody. Thank you, everybody. Thank you, everyone.
So, dear participants, this is the last session of day 4. So now we have 2 sessions tomorrow. So I will share the details in the WhatsApp group regarding the sessions for tomorrow, that is 18th of March 2023. Thank you, everyone. Have a nice day.
Thank you, sir.
Thank you. Okay, sir.
all of
Thank
you.
you so much. Thank you, sir. Thank you.